Section 1. Introduction. The world before our eyes. Look at a map of the world. See the continents separated by vast oceans. Imagine a time long ago when all these landmasses were joined together. This was Pangaea, the supercontinent. It existed millions of years before humans walked the Earth. Pangaea was a world unlike any we know today. It was a land of extremes. Giant mountain ranges rose up from the Earth. Vast deserts stretched across the land. Lush forests thrived in tropical regions. The creatures that roamed this ancient world were just as extraordinary. The story of Pangaea is a journey back in time. It is a tale of geological forces that shaped our planet. It is a story of life's resilience and adaptation. It is a reminder that the Earth is constantly changing. By understanding Pangaea, we gain a deeper understanding of our planet's history. We can see how the continents we know today came to be. We can learn about the forces that drive earthquakes, volcanoes, and mountain building. We can appreciate the incredible diversity of life that Pangaea fostered. Section 2. A journey back in time unveiling Pangaea. Imagine yourself transported back 300 million years. You stand on the edge of a vast inland sea. The air is hot and humid. Strange insects buzz around you. Towering ferns and giant horsetails dominate the landscape. This is Pangaea, a supercontinent that encompassed almost all of the Earth's landmass. It stretched from pole to pole, surrounded by a single global ocean called Panthalassa. The interior of Pangaea was likely a harsh environment. The climate was extreme, with scorching summers and frigid winters. Despite the challenges, life flourished on Pangaea. Forests of ferns, cycads, and conifers covered vast areas. Amphibians, reptiles, and early dinosaurs roamed the land. Insects, some with wingspans exceeding 2 feet, filled the air. The oceans teemed with life, including corals, trilobites, and early fish. Pangaea was a time of great change and evolution. The formation of this supercontinent had a profound impact on Earth's climate, geography, and life. It is a period of Earth's history that continues to fascinate and inspire scientists today. Section 3. The Dance of Continents. Formation of a supercontinent. The Earth's continents are not static. They are constantly moving, albeit very slowly. This movement is driven by the theory of plate tectonics. The Earth's outer layer is made up of several large plates that float on the semi-molten mantle below. Over millions of years, these plates collide, separate, and slide past each other. These plate movements are responsible for earthquakes, volcanoes, and the formation of mountains and ocean basins. The formation of Pangaea was a result of these plate movements. Over millions of years, the Earth's continents slowly drifted towards each other. Like puzzle pieces fitting together, they eventually coalesced into a single landmass. This process, known as continental drift, culminated in the formation of Pangaea around 300 million years ago. The collision of continents had a dramatic impact on the Earth's surface. Mountain ranges like the Appalachians were formed. Shallow seas were drained. New coastlines were created. Section 4. A world without borders. Life on Pangaea. Pangaea was a world without borders as we know them today. Animals were free to roam across vast distances. This led to a remarkable distribution of species across the supercontinent. Fossil evidence reveals that similar plants and animals were found in regions now separated by vast oceans. For example, fossils of the seed fern Glossopteris have been found in South America, Africa, India, Australia, and Antarctica. This suggests that these continents were once connected. The interior of Pangaea was likely a challenging environment for life. The vast distances from the ocean created a dry continental climate. Temperatures fluctuated wildly between scorching summers and frigid winters. Only the most adaptable creatures could survive in these harsh conditions. However, life found a way to thrive. Reptiles, well suited to dry environments, diversified and spread across the supercontinent. Early dinosaurs evolved during the Triassic period, and their footprints have been found in many parts of Pangaea. Around 200 million years ago, Pangaea began to break apart. This process, known as continental rifting, was driven by the same forces that created the supercontinent plate tectonics. As the Earth's plates continued to move, they began to pull Pangaea apart at its seams. The breakup of Pangaea began with the formation of a massive rift valley. This rift, which eventually became the Atlantic Ocean, split Pangaea into 2 smaller supercontinents, Laurasia to the north and Gondwana to the south. The separation of Laurasia and Gondwana marked a turning point in Earth's history. As the continents drifted apart, new oceans formed and widened. This had a profound impact on Earth's climate and life. The isolation of continents led to the evolution of unique plant and animal species on different land masses. The breakup of Pangaea continues today, as evidenced by the ongoing separation of the African and South American continents. The breakup of Pangaea was a slow and gradual process, occurring over millions of years. It was a time of great geological upheaval, marked by volcanic activity, earthquakes, and the formation of new ocean basins. The breakup of Pangaea had a profound impact on the Earth's geography. As the continents drifted apart, they took on their familiar shapes. The Atlantic Ocean widened, separating the Americas from Europe and Africa. The Indian Ocean formed as the Indian subcontinent broke away from Gondwana and collided with Asia. The movement of continents continues to this day. The Himalayas, for example, are still rising as the Indian subcontinent pushes into Asia. The San Andreas Fault in California is another example of the ongoing effects of plate tectonics. The breakup of Pangaea also had a major impact on the Earth's climate. As the continents drifted apart, they altered ocean currents and wind patterns. This led to changes in temperature and rainfall patterns around the globe. The isolation of continents also led to the development of distinct climates on different land masses. The evidence of Pangaea's existence is all around us. From the shapes of the continents to the distribution of fossils, we can see the lasting legacy of this ancient supercontinent. By studying Pangaea, we can gain a deeper understanding of the forces that have shaped our planet. Section 7. Climate change on a global scale. From supercontinent to 7 continents, Pangaea had a significant impact on Earth's climate. Its interior experienced extreme temperatures. The vast distances from the ocean resulted in a dry continental climate. The breakup of Pangaea led to significant climate change. As continents drifted apart, ocean currents and wind patterns shifted. These changes led to more moderate temperatures and increased rainfall. The separation of land masses resulted in distinct climates. For example, Antarctica's isolation led to its icy environment. The separation allowed for diverse ecosystems with unique climates. Studying Pangaea helps us understand Earth's climate system. It shows how continents and oceans influence global temperatures and life distribution. This knowledge is crucial for facing modern climate change challenges. Section 8. The evolution of life. How Pangaea shaped biodiversity. Pangaea played a crucial role in the evolution of life on Earth. The formation of the supercontinent brought together species from different continents, leading to increased competition and diversification. The vast, interconnected landmass also allowed for the spread of species over long distances. The breakup of Pangaea had an even more profound impact on biodiversity. As continents drifted apart, populations of plants and animals became isolated from each other. This isolation allowed for the evolution of new species on different continents, leading to the incredible diversity of life we see today. For example, the marsupials of Australia evolved in isolation after Australia separated from Antarctica. The unique flora and fauna of Madagascar are another example of the effects of continental drift on biodiversity. The isolation of islands often leads to the evolution of unique and unusual species. By studying the fossil record and the distribution of species today, scientists can trace the evolutionary history of life on Earth back to Pangaea. Understanding how life responded to the formation and breakup of Pangaea provides valuable insights into the processes of evolution and adaptation. Pangaea's lessons for humanity. Studying Pangaea holds valuable lessons for our future. It helps us understand the challenges we face today. Pangaea's breakup shows the impact of climate change on a global scale. It influences global temperatures, precipitation, and life distribution. Pangaea highlights Earth's interconnected systems. This knowledge helps us make informed decisions to protect our planet. Section 10. Conclusion: A lost world forever remembered. Pangaea, the supercontinent that once ruled the Earth, may be long gone, but its legacy lives on. It is a testament to the immense power of geological forces and the constant dance of the continents. The study of Pangaea continues to fascinate scientists and ignite the imagination. It reminds us that the Earth is a dynamic and ever-changing planet, shaped by forces that operate over vast stretches of time. It underscores the interconnectedness of all life on Earth and the importance of understanding our planet's history. Although we can only imagine what it would have been like to walk on the shores of Pangaea or trek across the vast interior of Pangaea, its story serves as a powerful reminder of the interconnectedness of all life on Earth and the importance of understanding our planet's history.